Hello, everyone. Welcome to Mining Match. This is your space for sharing your knowledge, your innovations, and just to create opportunity in the mining industry. As you can see in my screen, there is the the map of all the mining users, the Mining Match users in the world. I want to thank you, everyone, for supporting our community, and we will continue to work and to bring to you the best topics. Today, I invited a friend of mine and a colleague. His name is John Guo. Dr. Guo is a geochemist and is joining us from Quebec. And he has extensive experience in the mining industry for over 20 years in exploration and also in mining production. Hello, John. Welcome to
Hello.
Mining Match.
Yeah.
How are you?
Yeah, it's good. Good. Thank you. Thank you for your invitation. Give me the opportunity to introduce our technology and also our business to our colleagues here in this platform.
Yeah, thank you so much. So, John, if you can tell us a little bit about your background. So,
Yes.
how do
Okay.
you end up in founding this new technology in Eco-Goldex?
Yeah. Okay. I started my profession as a geologist first. I got my bachelor and the master in China.
Mhm.
I worked in China for 8 years before I came to Canada to
Okay.
University Chicoutimi for my PhD. I was with a major in geochemistry.
Mhm.
My profession or my background essentially is a gold guy. I've been working in the mining business for special mining operations for more than 20 years, mostly in gold. I
Okay.
started my personal investment in West Africa in Burkina Faso back to 2008 and all the way until 2011. That's from where I got the lessons, actually, I have to say. So this is where I start to think about how to can we, as a geologist, if you cannot find a cyanide by then, there's no gold for you, or you have to use like just a miner use water to wash it, which is 50% recovery. This is what we the reason we went there.
Okay.
So after that, I worked in a mining company in Quebec in the north, focused on copper, PGM, and nickel. And start
Yeah.
2016, I decided to run my own business with focus on precious metal recovery with an eco-friendly way. So this is
Yeah.
how I founded the company Eco-Goldex. The name Eco-Goldex means eco-friendly gold extraction. This is how the
Uh-huh.
name coming from. So now this business expanded very well, covered clients from more than 80 countries worldwide.
All
Worldwide.
right. Congratulations. Yes. Good.
Yeah, and our business or our service not only in the mining, especially for small scale miners, but also the e-waste, which now sometimes people refer as urban mining.
Yes.
Yeah.
Okay. Yeah, I think it's particularly interesting because as the mining industry moved toward a more friendly to the environment, I think that these innovations and technologies are very, very important to communicate to the mining community. So if you're ready, you can start doing your presentation, John.
Yep, I'm ready. Yeah, thank you everyone again. Yeah, today my talk mainly focus on the e-waste recycling, or sometimes people refer as urban mining. So first, come to the definition. Different people they have their different definition regarding what is classified as e-waste. Here, I just cited from website. The first paragraph here is e-waste refers to electronic product that are unwanted or not working or near or the end of their useful life. Mostly like old computers, old cell phones. And also in the past 20 years, the telecommunication box or televisions, printers, whatever, end of their life, junk, become junk, then throw away or recycled. So this is the dominant part. People usually refer as e-waste. But in my category, I also include the second and third point, which is decommission the solar panels, because solar panels, I will talk about later on, is really booming in the past 10, 15 years. And also catalyst converter from out-of-life automobiles. So in my definition, the e-waste include the three parts. And worldwide, every year there are about 70 to 90 million tons of e-waste material are generated. And only very small portion of them are properly processed or recycled. Most of them are end up in the dump site. And basically, China is the largest e-waste material producer, while the US is the largest e-waste export because they don't like to recycle because of the environmental regulations. And this chart shows the top 10 countries that generate most e-waste back to 2016. As I said, China is number one, US number two. They combine together, dominant by any other countries combined. And this chart, pie chart, shows the typical composition of material present in the typical e-waste, not referred to solar panel, not referred to catalyst, only the general e-waste like our junk computer and cell phone, for example. So from this chart, you can see the dominant material are metals, mostly copper, aluminum, iron, steel, whatever. And if you see our target material is the printed circuit board, which is the red part. So it's very small quantity in terms of percentage, 1.7. The majority are either other base metal or plastics. And this chart shows the value. So as I said, when people come to the recycling of the e-waste urban mining, mostly first reaction they have is recover gold. It's very true. From this chart you see, but again, this is back to 2016 statistic. In that year, the gold, total gold quantity in the e-waste is 0.5 kilotons with the value of 18.8 billion euro. So the quantity is very small, but the value is the number one. The second by plastics and the copper, other metals. As I said, solar panel has been widely used or the booming. This is what we call, especially in past 5 or 10 years. Everybody pursuing the green energy, sustainable energy, environmental protection. So a lot solar panels or what we call solar mill installed, especially in the US. If you go there, you will see like an ocean. So a lot of solar panels are installed when the solar mill. And in general, solar panels, they have a lifespan around 20-25 years. Start the very first generation of solar panel installation. Nowadays, there are quite a lot. This chart shows quite a lot of solar panels. They are reached their end of life cycle. They're put in what we call a warehouse or stockpiled. So far, there's no efficient technology for properly recycling of solar panels. In the US, only 10% of them are recycled. The rest either dumped in the dump site or keep in this warehouse, waiting for proper technology coming out. So you can see from this chart by 20, nowadays it's about between 100,000 tons more than. By 2030, it will be reached to 1.7 million tons. So it's increased exponentially because of the worldwide concern of environment protection. And this is the value distribution in the solar panel. You can see the silver is dominant, account almost half of the value of the solar one. This regarding in one solar panel. So dominant by silver and followed by silicon, aluminum, and then followed by silicon. And the third e-waste in my category is the catalyst converter. This has been very active in the recycling, car recycling business in the past years. From time to time, we heard, somebody's car stolen, somebody's catalyst convert stolen by theft because of the value, because of the PGM. This is because each car converter contains certain amount of platinum, palladium, and rhodium. And this is the reason and a function and how catalyst is used in car, mainly for the exhaust gas emission control, dirt air in and clean air out. And the PGM is used as a catalyst to convert those toxic gas into clean gas. And basically, each year, there are about 30 million catalyst converters are legally recycled. And the value of the market of catalyst converter market was back to 2018 was $42 billion. But by 2025, it will be reached to 73 close billion dollar in the market. So it's quite a big market. And here, this is what I want to show us. I guess our audience are mostly with background in the mining. And here, this is the PGM analysis of single catalyst converter. From this, we cited from a literature. You see, in each unit, the dominant PGM is palladium, and followed by platinum and rhodium. On average, you can see it's very high on average. So 720 ppm platinum and 1,580 palladium and 200 almost 300 ppm rhodium. On average, close to 2.5 thousand ppm in each single PGM. This is one of the reasons why there's so many cars got stolen, especially catalyst converter. It's very expensive, especially in the past years. The PGM, the metal, the commodity market, sky high. And now I just give a quick review. What are the current methods are used in the e-waste recycling? In general, there are two methods. One is pyrometallurgical method, which means burning, just simply burning. The second method is a hydrometallurgical method, which is hydro or wet method. The pyrometallurgical method only used in industrial countries, only operated by big company like big smelter. The advantage of this method is easy. It is easy, just burn, just smelt, and can process large quantity. But disadvantage is the air pollution and complicated post-incineration metal. Remember, everything just burn in the furnace, and then you have to find a way to separate the metals one by one. And of course, high capital investment requirement because you have to install all the exhaust air pollution control. Of course, if you are in a developing country, then that's another story. That is not covered by our topic here. So worldwide, only a few smelter worldwide accept e-waste also. One of them is Home Smelter in Quebec, just in Quebec, in northwest Montreal, about 700 kilometers away. Another one, big one, is the Mitsubishi in Japan. Those are the two major ones. There's another one in Europe, I believe in Norway somewhere. They accept e-waste for recycling. And this is the pyrometallurgical method. And the wet method, many use aquaregia. This is very commonly used for the individual small-scale e-waste recycler or hobbyist. I believe we know aquaregia is very dangerous, and the working environment is very poor. Means very stingy. You have to use protective equipment. It's very hard to go scale up for large scale operation, and also it's complicated process to separate all the metals from one by one, because aquaregia essentially digest all the metals. So you have to find the proper way to separate all the metals one by one from the pregnant solution. So basically, this is what's going on in the e-waste recycling market. First, e-waste recycling is considered the emerging business, and not. I mean, there's no really matured eco-friendly method to use this to recycle the material, and then globally only very small part of the e-waste are recycled by large or professional recycling company, like as I mentioned, like a large smelter center in Huanoranda, for example. Mostly are done by individuals or small scale miners, which is bearing a lot of environment impact. This is one of the reasons we get involved. And the most common recovered economic commodities from e-waste are gold and more partially silver. This is referred to the general e-waste. And for the catalysts and the solar panels, for the solar panels, it's mainly silver, and catalytic converter, as we already know, is mainly for the PGM. And as I said, the most common chemical method used is aquaregia, but it's hard used in large scale operation because of the its restrictions and operation costs as well. So based on those, the current situation or condition, so we get involved. We take another approach. First, we just analyze where are the gold or precious metals in e-waste. So those 3 points here, this is what we identified. First, we recognize the precious metal only exists in very small quantity, but dominant in value in the e-waste. For example, gold. And the second point is the precious metal are used in electronic parts or component because of their unique physical characteristics, mainly because of their superconductivity in both thermal and electricity. So for that reason, actually, they only used either on the surface, for example, in RAM, what we call the golden key, or connectors or pins. And in rare cases, used inside of electronic component as a wire, as very gold wire, especially for gold, and used, for example, in a processor and CPU, like those photos here you see. And for the silver in solar panel, silver wires are used. As I said, for its conductivity, it's a conductor to intercept the electrons in the silicon wafer to turn them into current. And the catalyst converter, the PGM, are coated actually on the surface of the ceramic honeycomb. So not inside, not everywhere, just on the surface. As the PGM act like small fine, very fine particle as a catalyst to convert the toxic gas into a clean gas, basically. So with those knowledge in mind, and also the quantity of metals, a precious metal in the e-waste, very small quantity, but with very high value. So we work out a flow sheet or a technology with our own features. So first, we classify the precious metal distributed in two groups. First, gold or plated gold, and the internal gold. With gold here, we use interactive use, gold or precious metal, both the same meaning. And we apply a layer by layer approaches. We don't process everything or to try to recover all the metals in one shot. Rather, we use one step, take one metals or one layers or one group of metals first, and then follow the next one. So we take that approach. First, we always take the first the surface gold first, and then the internal gold. And then also we apply our Eco-Goldex E-series stripping agent that is very unique in the selective stripping of precious metal, which means this solution, Eco-Goldex E-series agent mixed in water, this will form a stripping solution. This stripping solution only leaching or stripping precious metals. Like other metals like copper, nickel will be intact, lived in the as it is. And this stripping solution with a very, very efficient or stripping speed or dynamic, very, very fast, only a minute. It's amazing fast. And our system and the flow sheet can be customized based on client's requirement. You can go very small scale, 50 kilo per day, or 1 ton per day, or 10 ton per day. Depends on client's requirement, scalable, and also most important, eco-friendly. You can do anywhere. Basically, a lot of people even do in the backyard, in the garage, in the backyard, and of course, for large scale, they operate in their warehouse without special equipment. I mean, environmental protection. And another feature is, this is one of the reasons why we include solar panel and the catalyst converter in our e-waste conception, because our Eco-Goldex E-series agent has a very strong feature that one chemical applied to all, which means we can use the same chemical stripping solution to process e-waste and process solar panel and the catalyst converter. This is what I will talk about after. So this is a generalized complete Eco-Goldex e-waste recycling flow sheet. Looks like a lot of blocks. If you go through the block one by one, it's very simple. First, all the material will be sorted based on their quality of material, high quality, low quality. So first, then we strip in all the surface gold first. Once the surface gold is gone, all the pregnant solution was transferred to the pregnant solution storage. We apply electrowinning, direct recover gold directly, or the gold and silver, if there is any silver together, or the precious metal will come out together. They will be on the cathode. And this is the surface gold. And then after processing the surface gold, then we'll process the solder tin, which is act as a glue to stick all the component on the PCB board. Or this step, or the low quality PCB board, for example, like printer or like old DVD player. Basically, those kind of appliance, there's no gold, only copper and solder, whatever, low quality. We classify those material as a low quality, and we want to recover the solder from with our stripping solution. That's another process. Once this process is done, all the component will be separated from the PCB board. So at this time, the PCB board will be like what we call the bare board, because only board, there's no component on it. From here, from this process, we'll get the tin or solder ingot. And the separated electronic component and the PCB board will be separated. with our separating system. Then we have a steel coming out, and then we will collect. The most important part here is to collect all the IC chips and processors based on their size and the chip and the shapes. From there, we will crush and grind all the IC chips and the processors into powder. From here, this will come to the point we will recover the internal gold. From here, it's very easy for us who have the background in mining, pretty much like ore. You just crush the ore, grinding, and tank leaching. We do the exact same thing. And then we separate the powder with the pregnant solution. And then this pregnant solution will be sent back to the electrowinning to recover. So the electrowinning system is shared, either from solution from surface gold stripping solution or the internal gold leaching solution. From here, you have only the solid powder waste. And for the bared PCB board, there's no component, only the board. The board contains many copper wire. This is how the PCB coming from, printed circuit board. Printed wire, many copper plus plastic or epox. From there, we use a shredder or pulverizing system. Then we use air density separation to recover all the copper wire dust or chips and fine aluminum and fibers. So this is a complete flow sheet of the e-waste recycling process. In this, you see, as I said just now, we shared a lot of things, especially for the agitating tank leaching and IC chips crush and grinding in this part, not only for the IC chips and the processor, but also here we process the solar panel, grinding, pulverizing, and the catalyst converter as well. And here, this is the simplified, only cover the surface gold stripping recovery flow sheet. As I said here, the gold stripping system here, stripping, the first blue, I don't know, you can see my mouse. And then the pregnant solution come to the storage. And we have a filter and clean pregnant solution, and then delivered to the automatic electrowinning machine to recover gold directly. From this step, we can recover at least 80 to 85% of gold. And then the depleted solution were sent to the what we call absorption column. This step, we not only recover the rest 15 to 20% of gold, but also clean the solution before we can send it back to recycle. So our wastewater can be recycled through this process. This is the surface gold stripping and recovery flow sheet. And this is what is exactly the layout of the system. So the first, a lot of people, our client, refer at the boat. It's essentially like a boat, but with different cells or chambers for stripping process. And it is very efficient. This little machine, you can process at least 1 ton per day of e-waste. And then the solution comes to the storage for cleaning and filter, and apply the electrowinning machine to recover gold directly. And then the depleted machine solution will be processed in the absorption column for the cleaning of leftover gold and the cleaning of the solution as well, before sent back to the storage or recycling in the stripping solution. And this slide shows the internal gold stripping. As I said, the same boat can be used for solder stripping. Once the solder strip is done, most of the parts, components will be separated from the board. Then we use a shaking table. This shaking table is not the same as the shaking table we use in mining. We screener, basically, to separate the different components based on their size and shapes into different. Then the IC chips will come different slots, and those it's easy for us to understand. we just focus on the components, IC chips and processors. Then we have a ball mill and the crushing and the pulverizing, and then we have agitating tank leaching. Then we will separate the pregnant solution by a compressing filter. Again, the pregnant solution will be sent back to electrowinning machine for precious metal recovery. We share the same electrowinning process and cleaning process. This is the internal gold recovery flow sheet. And as I said, we can provide customized system for client based on their requirement. We can only do the gold, silver PGM recovery, or we can include gold, silver PGM and solder, or complete, which means we'll be end up with zero disposal of the e-waste. Depends on client's requirement. We provide turnkey solution. We not only provide the agent, but also system design, manufacturing, installation, training, and on-site technical support as well. So those are the show. Now I will show some photos, show how our Eco-Goldex E-Series stripping solution works. So this is photo actually is shared with us from our client in German. He's so excited about the product. So here on the top you see they did a different test. So on the gold plated pins, cell phone board, CPU and memories, different kind. And after stripping, you see all the surface gold. This is what we call referred as surface gold. All the coated gold are gone quickly, so quick. And the same, the pin on the CPU. And this memory card after stripping, this can be either a memory card or the video card. On the left hand side, lower part is another block. The top is the after, and the bottom is before, the gold plated. So those are the different material can be done easily and quickly without affecting the what we call the base metals underneath. Either copper or nickel. This is the example from our client. This is from Albania. We installed our system for our client. See, basically what they do first, the dismantle, the computer is like on the top right corner. They receive the junk laptop or server, whatever, and the people sitting there to dismantle the material, the parts, and sort them based on the quality. This is very essential step because different quality, they have different stripping time. High quality take a longer time, maybe usually 8 minutes. Low quality, just 1 minute. Or the stripping solution, stripping process will be done. So this is the sorting process. This is our stripping machine. It's as I said, this machine, you have 2 working cells and 1 rinse cell. This machine can process at least 1 ton per day. This system we installed in Hungary 2 years ago. And the right-hand side is the large one. Large system can process 5 tons per day. And this photo shows how the IC chips crushed, pulverized, essentially coming like a powder, as we see in the mining industry. They essentially come in the powder, and then the powder will be sent to agitating tank for leaching with the Eco-Goldex E-Series again, and then compress, separate the pregnant solution, and do the electrowinning. And basically, as I said, we can provide customized surface and system for our client. Basically, for 2 to 5 ton per day process facility, the cost will be $75,000 to $85,000 for complete system. And for 2 to 5 ton per day facility, you can roughly, based on the quality of the material, you can produce 63 to 185, 58 ounce of gold of gross revenue for 75,000 to 189,000 US dollar from gold alone. And this doesn't include silver and copper as credit after. So it's very easy to calculate the profit and the possibility how to run the business. The most important thing, though, is how to get the e-waste. That's a very important part. Yeah, basically, this is what I would like to share with you guys here. And if you have any question, I'm ready here. I will be happy to answer your question. Thank you.
Okay, John. I'm going to go back now to the screen. This is a very impressive presentation, John. I'm an advocate for better technology, and especially now that the mining industry has this challenge of providing the metals and minerals that everybody needs in the daily basis. So to our audience, please feel free to type your questions in the chat. Is now available. We will wait for a few seconds while I will talk to John about questions I have for you. So John, you know, in mining, we talk about grade, amount of metal per ton of rock. How is it in urban mining? So in the e-waste, how do you measure that amount of metal that you can recover for a ton of e-waste?
That's a very good question. Actually, for the general e-waste, here, I would like to refer here. For general e-waste, the gold alone can be anywhere between 200 grams per ton to 1.5 kilo per ton. Only for this, for gold.
You say gold?
Yes.
So,
that's for gold. For general e-waste, so low, it depends. A lot. Actually, this is a very common question. Many times asked by our client. They want me to tell them, John, how do I know how much gold I have in the e-waste? I said, depends. Even with the same RAM, for example, the memory card, the function is the same, but depends on the brand, depends on the year, depends on the manufacturer, who made it, which year. In general, in this e-waste, the summer rule is the older the better. Say if the computer is made in, say, back to 1980s, there's more gold.
Lot of, yeah.
Yeah, and the military grade is always high grade gold, high quality gold.
Yeah, it's pure gold. Like there's no such thing as no. They use the actual high purity gold, right? So
yes, exactly. So in general, for general e-waste, you can have gold 200 grams per ton to all the way 1.5 kilo per ton.
Wow, that's very high grade.
Yes,
in mining terms, right?
In mining this terms, is why we call it now as we refer to as urban mining. It's very high grade.
Correct.
The only matter is how you get the material. So just for example, yesterday I have a client in California. He installed a system, and he got a lot of, because they are mostly the large operator are mostly recycler of electronic recycler. Yeah. They can get this material easily from local supplier, like electronic manufacturer, for example, like LG or Apple or Samsung. So this one of the hot spot or countries with most recycling operations. It's Mexico. In the past 5 years, I have a lot of system installed there.
Okay. So as you said, the challenge here is how to get the most e-waste from the city or from collecting.
Yeah, for example, piece by piece. In Canada, we have a local what we call eco center. Some recycling company every year they have a dedicated date to receive what we call junk electronic device, because those devices cannot throw away anywhere. You have to have a dedicated collectors to collect it. And some large designer or manufacturer, they have their own what we call research center. Basically, the one of the example is there's a CFM electronic recycling center here in Quebec. Every year they receive tons of, not every year, every month they receive tons of e-waste from some research center, because they printed, they designed a lot of. Remember, electronic device or technology evolve very quickly. So which means they designed last year, and after this year they realized, oh, this technology is out of date. The PCB board doesn't fit the market at all. So what they do, they just resend to the recycling, because they don't want this close to the market. They just send to the recycling company to destroy everything. This is what we heard, we see very often. But in general, the good thing is this is something very unique worldwide, regardless of the country, the poor or rich, or big or small. Every country worldwide, you use cell phone. Every
Yes.
family you have a TV.
Billions of cell phones go to the garbage. Yes.
Yes. So cell phone usually 2-3 years, and after that you have to replace a new one. But unfortunately, most of the cell phone they're not properly recycled. But some country like Mexico, again, I cite this country because I visited this country several times. A lot of people goes village to village to collect all the old cell phone, and with small changes, or trade with other items they need, and then they resell to the local collector.
Right.
And it's one of the very big, is the way, one of the way how to recycle.
So, okay, if we understand the business, we have a question. I'm going to go to you with your question in the chat. Thank you. So, for people to understand the business, if they want to go into urban mining, now the whole economic outlook is like one of the biggest costs is to get the e-waste. Then the capital expenditure of setting the plant that you will provide all the turnkey solution.
Yeah.
And then the operating costs, like you also supply the agents, what is the consumption that they need per ton, or how does it work?
Oh, the operating cost. This is also one of the commonly asked questions from our client. The daily consumption or operating cost extremely low. Say, for example, our Eco-Goldex E-Series agent, 25 kilo bag, 25 kilo. If you buy from retail, for example, it will be $500.
Okay.
But with $250 if you buy bargain. And with that bag, you can process at least 2 tons of e-waste. So basically, what I told our clients, say, don't worry about the cost from our side. You can count very minimum 10% in the total. The only cost they have to concern is how you get the material. If you can have a steady supply of the material, you are in the business.
Yeah, so it must, when you work numbers and cash flow, you must have $1 per ton of e-waste to collect and be ready to process, right? So that is one of the key challenges in getting this business running.
Yeah.
Well, I'm going to read the question from one of the persons in the audience. He says, do you use eco-friendly leaching agents?
Yes, the answer is, this is what we call Eco-Goldex E-Series agent. It's the only agent we use in the leaching process.
Okay, and this is the one that costs $50 a bag of 25 kilos? Okay.
Yeah, this is the only chemical we use. in the whole process. If for large operation, the rest part we use in the convening process to recover. So you don't need to use any acid
Right.
in the process. That's only chemical.
Now, in the analogy, comparing this to an actual conventional processing plant that you have tailings, what is the residuals in this process? You said that the water is recycled, but is any sort of tailings or just process e-waste?
Okay, you mean the residue after the process?
Yeah, after the process, what is that? Is your residuals? What is it?
Okay, the residues here, as I said, if you go complete processing, technically there's no residue, because or even the fiber we can recover, and actually we can use that fibers as a construction material.
Oh, okay.
Yeah, the water will be recycled or the metal will be recovered. The
Right.
plastic recycled. So everything will be recycled. There's zero. Technically, there's a zero. Remember, there's one chart from the internal gold. We have a crushing process
Yeah.
after leaching, like pretty much like a mine, right?
Yes.
As the chips, there's a powder. That's black powder. Also, after leaching process, that's essentially like a plastic. We can send it back to the recycling.
Okay, so
Yeah, that's
so
essentially
all
there's
components
zero
of the e-waste are recycled completely,
recycled.
metals and plastics
Yes,
and solder. Okay.
yes.
Okay. If anyone in the audience, please, you have your chance to ask your questions now. Otherwise, we will be ending this presentation now. Okay. A few seconds. If you type, we answer. Otherwise, next time. John, thank you so much for your time and for this interesting presentation.
No problem.
We will
Thank you.
be promoting this and putting on our website in Mining Match.
Okay, great. Thank you.
Thank you so much. Have a wonderful
you.
day.
Okay, bye.
Okay, all the best.
Bye.
All right, ladies and gentlemen, thank you so much for attending to this interesting webinar of how you can process e-waste and start your own business in urban mining. You know, the mining industry is very diverse. Let's say the conventional mining is to get the metals and minerals from the rock, that's the source. But in this case, you will recover the metals and minerals from e-waste, material that already being mined and used in electronics, right? So I think this is a very good initiative, and I congratulate John for all this, bringing this solution to the market is a very good initiative and collaboration in the efforts of becoming more responsible in mining and to work under sustainability principles. Thank you so much for being here with us, and I'll see you next time. Have a good day.